I'm glad to invite Roger Malina. Roger Malina is an astronomer, director of the Laboratory of Marseille and editor of Leonardo, Massachusetts Institute of Technology Press.
Good afternoon. I feel like this is part of an ongoing conversation because a few weeks ago we were in Trondheim, some of us, and I talked about the situation of big data, of how we've gone from a situation of data scarcity to a situation of data plenty, and how that, I think, affects a number of questions about how we understand the world. Today, I want to talk about sort of the infrastructure that data flows through, and so I want to talk a little bit about the science of complex networks. So I'm not talking about the science of complexity here, but really the new mathematics and science that's been going on in the last decade looking at the structure of networks. And I want to talk about some of the implications of that. Maybe in my third talk I will couple the data flow with the network structure question. Before I go into my topic, I just wanted to mention a couple of documents. It turns out that 10 years ago, almost to the week, I was in Paris near Florence in Italy, where David Peat organized a small workshop on the future of the academy. And the discussion here really was very familiar. And if you Google David Peat online in Paris, you will find the report that was written coming out of that workshop. David Peat, of course, was a student of David Bohm's, and the workshop was infused with that perspective of the world. The other document that I want to mention is one that came out this year, which David Goldberg and Kathy Davidson edited, called The Future of Learning Institutions in the Digital Age. And I think they did quite a good job of repositioning the question in the current situation. So I would recommend to you those two references, which you'll find online very easily. And I think that it connects to the comments I want to make about complex networks and the structure of networks. So as I mentioned in my opening comments, over the last decade, there have been a number of researchers really looking at the mathematics of networks. And I think there are a few really interesting ideas that are coming out of that. Now, some of you, when we were in Prague a few years ago, met Laszlo Barabazi, who's one of the names associated with this emerging new discipline. But I think what's interesting is here is a growing technical understanding how the structure of networks can be understood, and in particular how certain structures enable certain kinds of behaviors and other structures suppress certain kinds of behaviors. This is kind of a new connectionism, if you like, almost a structuralist view of the way that things are organized in the world around us. And what's quite remarkable in the work of these researchers, I think, is that they found a number of laws, and I say that in a weak sense, that are applicable to network structures almost independent of the area of application. And so it applies in chemical networks, biological networks, physical networks. And there are a number of ideas that have been discussed quite broadly, both in the popular literature and the technical literature, looking at scale-free networks, of course, the small world phenomenon, the 6th degree of freedom problem. But more recently, they've been looking at the dynamics of network structures, analyzing them with techniques that are almost like statistical mechanics, looking at burst phenomena and the way that the evolution of networks doesn't happen in continuous ways, but in various kinds of discontinuous ways. And of course, the whole set of phenomena that we sometimes call the long tail phenomena, because indeed the world is not organized around the mean, but very rare events can have very big influences on the behavior of systems. On the right is a network that actually came from two researchers in Holland, where they looked at the 45-year history of the Leonardo publications. We've published something like 6,000 people over those 45 years. And they looked at all the citations coming into the publication and going out of the publication.